Hello guys, you're welcome to my channel. Today we want to look at circular motion, and I believe after today's class you will have no issue in solving any question on circular motion again. Before we commence the class, please, if you are yet to subscribe to this channel, kindly subscribe now. It's for free. You are the only one that can help me to reach 100,000 subscribers. Kindly like this video, drop a positive comment, and tell me how you want me to improve. Thank you. Now, let's look at the circular motion. When you talk about circular motion, we all know that circular motion is the motion of an object in a circular path. That is, if I have a circle like this, and I have that a body or an object is moving around this circle with a constant speed, we said that body is performing a circular motion. Now, before a body can perform a circular motion, there are some certain things that must be in place. I would like you to consider these vectors. If I have a force vector and I have a velocity vector that are both facing the same direction, whenever you have what? A force vector and velocity vector facing the same direction, what will happen to the speed of such object is that the speed would be increasing. There's need for us to understand these characteristics before we go into it deeply. But if I have that the force vector and the velocity vector faces a opposite direction, what will happen to the speed of the object is that the speed would be decreasing. Now, if I may ask you, what will happen if the force vector is perpendicular to the velocity vector? What will happen to the speed? You can pause the video and give answer to it. Okay? Now, whenever you have the force vector and the velocity vector perpendicular to each other, what will happen is that the speed of the object will remain constant. As the speed remains constant, this force that is perpendicular to this velocity would cause the object to move in a circular path. So this force is what causes this object to move in a curved manner like this. And the velocity will then face up like this, while this force will still be perpendicular to the velocity. This perpendicular force will cause this body to curve again. This velocity will then be facing this direction and the force will still be perpendicular to it. As this force is perpendicular to this, it's going to cause this body again to move in a curved path, whereby the velocity will face this direction and the force will still be perpendicular to it. As the force is perpendicular to it, it will cause it to move. Now, if you look at it now, if I draw this diagram perfectly like this, you see that this force caused the body to move in a circular track because this procedure would continue. Now, if you observe that, you will see that the object will continue moving in this circular track and the speed is constant. Whenever a body moves with a constant speed in a circular track, we said it's performing a circular motion. But if you observe the velocity keeps changing its what? Direction. That is, the speed of the body is the only thing that will be constant, but the velocity will keep changing direction as the object also changes its direction. And if you observe the force at every instance, you see that it's pointing towards the center. As the force passes towards the center, the acceleration would also be what? Moving towards the center. Hence, the force that is pointing towards the center is known as the centripetal force. And the acceleration, according to the second law of motion, we have that F is equal to what? ma, mass times acceleration, where mass is constant. Wherever the force is facing, that will be the direction of the acceleration also. Now, as the force is pointing towards the center, the acceleration is also pointing in the same direction. Hence, we can bring out the following characteristics for a body that is performing a circular motion. That is, 1, the force is directly towards center. Likewise, the acceleration is towards the center. And the speed of the object is constant, and the velocity is always what? Changing in a direction. So I will state the 4 characteristics again. 1, the force is directly proportional to the center. The acceleration is also directly proportional to the center. The speed of the object remains constant while its velocity keeps changing. And if you look at the velocity at every instance is at a tangent to the path. Those are the characteristics of a body that is performing a circular motion. Do we get that now? Now, what will be the value for the centripetal force that caused the body to move in a circular path? That is another thing that we need to know. The centripetal force that caused the body to move in a circular path is given as mv squared over r. This is the centripetal force, and let's call this equation 1. And we all know that F is equal to mass times acceleration from the second law of motion. Now, if F is mass times acceleration, hence centripetal force will be mass times centripetal acceleration. If I slot this into this, I'll have that mc is equals to mv squared over r. So m and m would cancel, then I have that the centripetal acceleration is v squared over r. So I can call this the second equation. So you see this now, centripetal force is given as mv squared over r, and we know that force is mass times acceleration, and centripetal force will be mass times centripetal acceleration. So it means this and this are equal. That's why we have what? ma to equal what? mv squared over r. So m and m will cancel. I have what? Centripetal acceleration to be v squared over r. Now, you may be asked to look for what? The speed of this body. What will be the speed of the body? We all know that if this body moves in this track, then velocity is the same thing as displacement over what? Over time. So let me call this equation 3. Then I'll come back to that equation 3 after I explain this. Whenever a body completes what? A circle, if this body starts from this point here, and the body rotates down back to this point, the body has completed what? 1 revolution. And whenever a body completes what? 1 revolution, we said the time that takes the body to complete that revolution is called what? Is called period. That is, the total time taken for a body to complete 1 revolution, or you call it 1 circle or 1 oscillation, is known as what? A period. And also, the number of revolution per second, the number of revolution per second, or the number of oscillation, or the number of cycle completed per second is what we call frequency. So if you look at that, you will see that the period of oscillation is going to be the time divided by the number of cycles. And the frequency is going to be the number of cycles divided by the time. Do we get this now? So if you look at this now, you will see that the time, which is the period, is like inverse to that of what? Frequency. Hence, I can say that period is 1 over frequency. Also, frequency is 1 over period. So let's call this one equation 4 and call this one equation 5. Now that I know this, let's come back to this. If I come back to equation 3, where I have displacement over what? Time. I can call this one distance also. If a body is moving in a circular track like this, if it completes what? One circle, it has covered a distance that is equivalent to the circumference of the circle. And the circumference of the circle is given as 2 pi what? 2 pi r. If that should be the case, the time that will take the body to complete one circle is what we call period. Hence, we can say that velocity is equals to 2 pi r over t. Now, if you now recall that, this I can write it as saying that v equal 2 pi r multiplied by 1 over t. So 1 over t is the same thing as saying what? Frequency. Hence, I can say v is equals to 2 pi r times what? F, which I can rewrite as 2 pi f r. Now, I would like you to recall something. Here, let's call this equation equation 6. But I would like you to know that 2 pi f is the same thing as saying what? Angular velocity. So if angular velocity is 2 pi f, I can say my linear velocity is omega r, and this is equation 7. So are we getting that relation? That is, linear velocity is angular velocity times what? Radius. And at the same time, angular velocity is linear velocity divided by the radius. So let's say this is equation 8. So from equation 7 and 8, I would like to come back to equation 2. Now, if you look at this equation 2, I don't mean to clean this because I don't want to clean any of the equation yet. Now, A, which is centripetal acceleration, is V over R. So V is what? Omega R. So if I slot in omega R all square divided by R, and this is equivalent to omega square R square over R. Hence, centripetal acceleration can also be written as omega square R. And this would be what? Our equation 9. So it means I can express what? Omega, I can express centripetal acceleration in terms of what? Angular velocity. Like I can also express it in terms of what? Linear velocity. Likewise, the centripetal force. The centripetal force is mass times acceleration. So mass times centripetal acceleration, and this is equivalent to mass times centripetal acceleration in terms of angular velocity is what? Omega square r, and this is our 10th equation. All these are useful what? Equation in circular motion. Now, let's quickly go back to the fact that what are those things that causes the centripetal force? Because aside from all this formula, the next thing that can give you a problem in solving question on circular motion is the fact that if you don't know what the forces that produce a centripetal force at every instance. So let's look into that now. So if I have a body that is performing a circular motion, that is, for instance, if I have a string and I attach what? A lemon, or I attach a stone to that string, and I'm what? Wheeling the string like this, the stone will be performing what? A circular motion. Now, the tension in that particular string is what produces the centripetal force that's sufficient to cause the body to move in a circular track like that. So, whenever you are using a string, if you are wheeling a string like this, that is, you attach a stone or an object or to the end of the string, and you are wheeling the string like this, the force that will produce the centripetal force needed is going to be the tension in that string. So, it means that the centripetal force can also be equivalent to the tension force. Are we together? Okay, that is one. And two, if I have that a body is like for instance the moon and the earth. You know, the moon is the satellite to the earth. The moon is revolving around the earth. What is that particular, you know, if this is the track in which the moon is moving, and this is the earth, we have this to be the earth, and we have this to be the moon. The moon is what? Moving in a circular track around the earth. What produces necessary centripetal force for this moon? The force that produces centripetal force is known as the force of gravity, because the force of gravity is causing the earth to attract towards the moon. Likewise, the moon is also attracting the earth. These two forces are equal but opposite, and they are the one that produce the necessary centripetal force. Hence, we can say the force of what? Centripetal force can also be equate to what? Force of gravity when we are talking about planetary motion. Are we together? Okay, now let's look at the last condition now. So if I have a body like a car, if I have a car like this that is moving in a circular track, like a roundabout, like this. So if I have a roundabout and a car is moving like this, you know, the car will continue performing a circular motion. Now, the question is, what produces what? The necessary centripetal force for this car to continue moving in the circular track. Now, the friction between the tire and the road is what produces what? Necessary centripetal force for the car to move in the roundabout manner. Hence, we can say the centripetal force can also be equivalent to the frictional force. And that will make me look at some case. If instead of this car, we have what? A bike that is performing what? A circular motion like this. If you are asked this question, that at what angle will you what? Will the bike man place the bike such that it's not going to slip off? The question is a technical question that if you don't understand the force that produces what? The necessary centripetal force, you might not be able to answer that question. Let's look into that now, and we are going to what? We are going to derive an expression for that. Remember, instead of what? Instead of a car now, you have what? A bike that you want to use to move what? Around this roundabout. Then you will ask that at what angle are you going to place the bike so that it's not going to slip off while performing the circular motion. Let's quickly look into that. You know, we are told that when a body like a car is moving around a roundabout, what produces the centripetal force is the frictional force. So if the frictional force is given as mu, which is the coefficient of friction multiplied by the normal reaction of that particular body, that is the weight of the body, mg. If I call this the first equation here, and we have that centripetal force is mv squared over r. So if I call this equation 2, because the frictional force is what produces what? The necessary centripetal force for such body, it means they are equal. So we have what? mv squared over r to equal what? Mu mg, like this. So the mass will cancel each other, where we have what? V squared over r equal mu times gravity. Are we together? If I make mu the subject of the formula, I will have that v squared over gr, like this. So if I call this one equation 3, remember we are looking for what? The angle that you are going to place the bike such that the bikeman will not fall and the body will perform what? The circular motion. Now, I would like to recall that mu is the same thing as tan of theta. If you remember, I'll quickly write it here. The normal reaction is given as mg cos of theta, and the f is given as mg sine of theta. Then we have coefficient of friction to be f divided by r, and this implies what? Mg sine of theta divided by mg cos of theta. This and this will cancel. Then we have the coefficient of friction to be sine of theta over cos of theta, which is going to give us tan of theta. Hence, mu is equivalent to tan of theta. So I will replace that with this. So I have that tan of theta is v square over gr. So theta, which is the angle that we are looking for, is arctan of v square over gr. Okay, let me write the r well. So this will be the value for the angle that you are going to place the back. So this is equation what? Equation 4. Now before we start considering what some problems on circular motion, I would like us to look at a case whereby a circle is now being wheeled vertically. Instead of wheeling it what horizontally like this, then is now being wheeled vertically. How can you get the tension in the string? How can you calculate for some certain stuff at every instance? Let's quickly look at this diagram here. Okay guys, I believe you are getting this explanation gradually. Okay, if that should be the case, let's quickly look into that. Let's say we have a circle like this, and we are wheeling this circle vertically. The weight of this object is like this, it's pulling down like this. That is mg. And we have what? We have the necessary centripetal force to equivalence to the tension force. Now, if you look at this now, we have what? We have that this tension force is not directly, it's not what? Directly straight. That is, it's not straight perfectly, but you know that the centripetal force will be absolutely straight down like this. Now, if this is the tension required, then it means the tension is going to have what? A vertical component, and is going to have an horizontal component. Remember, this is the angle between what? The centripetal force and the tension. Now you're looking for the tension in the string that produce what? This centripetal force. How can we get this now? So we have to look for the vertical component of this and the horizontal component. So the horizontal component, remember this vertical component is equivalent to the weight of this object. Are we together? And this is the horizontal component, which is equivalent to the centripetal force. Are we making sense? The horizontal force of this particular tension in this string is given as what? The centripetal force. Although it is approximately the same thing, but not exactly the same thing. So the centripetal force is the horizontal component of this tension, and the vertical component of the tension is the weight of the body. Now, if this one is equals to what? Mass times centripetal acceleration, then this one is equals to what? The weight of the object. Am I making sense? If that is the case, then the tension in the string is going to be the square root of tx squared plus ty squared. So this is going to be the square root of ma all squared plus mg all squared. Hence, this is the same thing as saying m the square root of a plus the square root of a squared plus g squared. I believe we understand this now. So this will be the tension of the string when you are what? When you are wheeling it horizontally. And this is approximately the same thing as centripetal force. You will see that when we start considering what question. Now, they can decide to twist the question in another way. You know, this is when what? Vertical circle. So I can call this for a vertical circle. Now, I'm still considering what? A vertical circle. But let me clean this one so that you can see what I want to explain clearly now. If I have a case like this, and the question now says, what will be the value for the tension in the string at every instance? That is, let's see, this is point A, this is point B, this is point C, and this is point D, like this. If the question asks you that, what will be the tension force at the point A, or what will be the tension force at point B, or what will be the tension force at point C, or what will be the tension force at point D? Or the question can come in another way around and say, what will be the tension force at the bottom, what will be the tension force at the middle, and what will be the tension force at the top? How can you get that? I would like us to understand something. If I have a string and I'm rotating it vertically like this, you will observe that whenever the body is about to move up from bottom, if it wants to move, that is from this point, if it wants to move to this place, it's going to you're going to feel you're going to feel the object to be more heavy than when it is here, or when it is here. That is, at this point, it requires more force to take the body up here. But when it gets to this point here, you see that it falls freely. Why? Because there is no need for extra work here, as gravity is going to push the body down. At this point, the tension force here is equivalent to the weight of the body, because weight is the gravitational head pull on a body. Now, at this point now, we have that the tension is the same thing as the weight. And at this point, we already have the tension to equal the centripetal force. But at this point, two things is required. You need a force to overcome the weight of the body so that it can lift, and also a centripetal force that will make the body to move in a circular track. Hence, at this point, the tension in the string is going to be mg plus ma. So we can see now that at this point, that is at the bottom, the tension there is going to be the weight times the centripetal force. And at this point, which is the middle, the tension force is equivalent to the centripetal force. And at the top, the tension force is equivalent to the weight of the object. I believe we understand all of this explanation. Thank you. Whatever complexity that you might find in this, you can let me know in the comment section. I will definitely attend to you very fast. Now let's consider some examples now. Example 1. So here is question 1. We are asked to look for the length. We are told that the length of the seconds hand of a laboratory clock is 0.1 meter. Calculate the speed at the tip of the seconds hand. You know, when you have a wall clock, it has 3 hands. We have the second hand, we have the minute hand, and the hour hand. We are now told that the second hand, if the length is 0.1 meter, we should calculate the speed at the tip. Okay? It's a very technical question, but we can overcome it. Very simple. It's a practical question. If you look at something, we know that you start from where you know that speed is given as a distance all over time. You should know that. Now, if you want to solve this question appropriately, before you can count the second hand to be working, because what you are after is for you to calculate minute, or for you to calculate hour. You don't usually calculate second, isn't it? Like if I ask you to go and check the time now, you can just tell me that it's 3:15. That is 15 minutes past 3. Or you tell me that it is 12 minutes past 1. Are you getting it now? You don't tell me the second. Automatically, the second hand, before it's relevant to us, it's when it gets to minute. And before a second hand can count minutes, it must have moved 60 seconds. So when the second hand moves 60 seconds, it means it has complete 1 circle. And the distance of 1 circle is the circumference of the circle. That's 2 pi r. Are we together? Divided by the time that it takes the body to complete 1 minute is 60 seconds. Are we together? So that's the period. Are we making sense now? Good. Now this will be 2 times pi, then times, what will be the radius? If you look at the second hand, it's from the center of the circle to the circumference. Hence, the length of the second hand is our radius, and that is 0.1, then divided by 60. 2 here will give us 1, and 2 here will give us 30. So we have 0.1 pi divided by 30. So the speed V is going to be 0.1 times 3.142 divided by 30. And what would this give us? So let's quickly look into our calculator. So we have 0.1 multiplied by the pi, and then multiplied by 30. Sorry, now should be divided by 30. So divided by 30. So we are going to have the 1.05 times 10 raised to power minus 2 meter per second. And that will be the speed at the tip of the second hand. It's as simple as that. Now question 2. A particle moves in a circular orbit of radius 0.02 meter. So we write down first the radius. We are given the value of the radius to be 0.02 meter, like that. If the speed of the particle is 0.88 meter per second, that is, the speed is 0.88 meter per second, like that, calculate its frequency in circle per second. So we are looking for its frequency. So you will ask yourself, what is the relationship between what? Radius, velocity, and frequency. Which of the formula give us that? Remember that we know that V is equals to what? V is equals to distance over time, isn't it? And we are going to recall from the formula stated earlier that V is omega times what? The radius, right? And omega is 2 pi what? 2 pi f. So it means that this is the same thing as saying 2 pi f times what? R. Hence, V is equals to 2 pi f times what? R. So what's our V is 0.88 to equal what? 2. So we have that V equal what? 2 pi fr. Then our V is 0.88 equal what? 2 times 22 over 7. Then multiply by what? F. We don't know the value for F. Then multiply by the radius, which is 0.02, like that. So let's make F the subject of the formula. We have 0.88 to equal what? 2 times 22 times 0. So let me just write it like this. That this is 44 over 7 times F, then multiply by 20 all over, multiply by 2 over 100, like that. So this will give us 0.88 can be written as 88 over 100. So if I have 88 over 100, this will give me 88 all over what? 700, like this, because 7 times this will give us 700 what? F. Are we together? Now let's make F the subject of the formula, but before then, this and this can cancel. So if that should be the case, I can just come here and say that this is 88 equal what? 88F divided by 7. So if I cross multiply, I will have that F is equal to 7 times 88 divided by 88. So this and this would cancel. Then we have what? 7 circle per second. And that gives us what? The value for the frequency. Do we get this now? So let's consider the third question and the fourth question. Okay, this is question 3 now. So it's a plane moving at 400 meters per second makes a circular turn of radius 3 kilometers. What is the centripetal acceleration in G's? Let's see. Okay, no matter how worse for a student, he or she would be able to write the word solution. Okay, that's true. Okay, if that should be the case, let's start from what we know. A plane moving at 400 meters per second That is, the speed is 400 meter per second. Makes a circular turn of radius 3 kilometer. The radius is 3 kilometer. What is the centripetal acceleration in G's? So we are looking for centripetal acceleration. Mind you, the centripetal acceleration usually be in meter per second square. How are we going to express it in G's? That's just the logic there. It's not a difficult question, because we know that centripetal acceleration is just v square over r. So it's so direct. So let's do that. Let's start from where we know. So this is going to be 400 r square divided by the radius. But this radius is in kilometer. Kilometer is not a fundamental quantity. So you have to convert this to meter, and that is 3,000 meters. So you multiply by 1,000. So this is going to be 3,000, and this will give us what now? So 400 square is going to give us 160,000. So we have that our centripetal acceleration is 160,000 divided by 3,000. So this and this will take care of each other. So we have what? 160 divided by 3. So this will give us 53.33 in meter per second. Meter per second square. You know, that's the normal unit we know for acceleration. But they don't want us to express it as meter per second square now. They want us to express it in G's. Now you will ask yourself, how many G will make what? 53.33 meter per second square. Let's quickly look at something. If I have that 1G is equivalent to 9.8 meter per second square, so 2G would give us what? That should be 19 point something. So 9.8 times 2, so that's 19.6 meter per second square. So how many of these will give us what? 53.33 meter per second square. So that's just the question, but it's very simple. What we just need to do is that we already know the conversion factor, that is 1G is the same thing as what? As 9.8 meter per second square. So if that should be the case, for me to convert this one to G's now, I will just have that this is 53.33 times, this is G. So I have what? 1G to be divided by 9.8. Normal we would convert. So this now will be A, that's 53.33 divided by 9.8. So what would this give us now? So we have 5.44 G's. So 5.44 G's is going to give us what? Is going to give us 53.33 meter per second square. And this will be our what? This will be our answer. Do you get this now? Good. Okay, so let's go to the second question. So we have that an object of mass 6 kilogram. The mass of the object is 6 kilogram. Is wheeled round a horizontal circle of radius 3 meter. So the radius is 3 meter by a revolving string inclined to the vertical. Calculate the tension. So we are looking for tension in the string. If the uniform speed of the object is, that is the speed is 9 meter per second. And we are given that G is equal to 10 meter per second square. As a matter of fact, the value of G is going to be approximately the centripetal force, because what? The centripetal force is caused by the what? By that tension. So the tension is approximately what? The centripetal force. Not exactly, but approximately. And let's quickly look into that. I will show you now that it is approximately. So if you look at that, I have that centripetal force is mv square over r, right? So this is going to be mass, which is 6 times v, which is 9 square, divided by the radius, and that is what? 3. So I have that F is what? 6 times 81 divided by 3. 3 here 1, 3 in 81 will give us what? So let's check that. 81 divided by 3. So that will give us 27. So we have 27. So 6 times 27, we have 162 Newton. So this is our centripetal force, which we have that centripetal force is approximately the tension force, and that is 162 Newton. Now let's confirm this by calculating the tension the normal way we're supposed to do. So we have that the tension is going to be the square root of what? Okay, sorry. The tension is going to be m square root of a square plus what? Plus g square. So let's quickly calculate for centripetal acceleration there. So what will be the centripetal acceleration? V square over what? R. So we have the V to be 9. So we have 9 square divided by what? 3. And that will be 27 meter per second square. So that's our A, and our G is given to be 10. So the tension is going to be the mass, which is 6, then multiplied by 27 square plus our G, which is 10 square. And this is equal what? This is going to give us 6 times the square root of 27 square plus 100. 27 square plus 100. So that will give us what? 829. So square root of 829, that will give us 28.79. So tension is 6 times 28.79. So let's quickly see what that value will give us. So this gives us 172.75 meter per second. Sorry, this is going to be in Newton rather. Oh, they are absolutely different. Okay, so this is not correct, and this is going to be the right one. Are we together now? Good. So let's look at the fifth question. So this is going to be the right question, the right answer to the question. So the fifth question now. So we have that an object of mass 15 kilograms. So we write that the mass of the object to be 15 kilograms is wheeled round a vertical circle of radius 3 meters. The radius is 3 meters with a constant speed of, so the speed is 4.5 meters per second. Find the maximum tension in the string if G is 10 meters per second square. Mind you, when they say speed, is the same thing as velocity in magnitude. But velocity is a vector quantity. Are you getting it? Why speed is a scalar? But in magnitude, they are equal. The difference is just that one has direction and the other one does not what? Have. So don't get confused. Now we are looking for the maximum tension. Remember the other time that we are explaining what? The vertical circle. We have that the tension is said to be maximum here, where we have mg plus what? The centripetal force. So we can just calculate for the centripetal force here, which is what? mv square over r. Abi? So we have what? 15 times 4.5 square divided by what? By 3. So this is 1 and this is what? 5. So 5 times 4.5 square. So 4.5 square multiplied by 5. So we have what? 101.25 Newton. So we are now going to say the maximum tension is going to be what? Mg, which is the weight of the object, plus the centripetal force. So the mass of the object is what? 150 times the what? The gravity, which is 10, then plus the centripetal force, 101.25. So the tension force is going to be 150 plus 101.25. And this will give us what? If I add these two together, I should be having 251.25 Newton. And this is the maximum tension on the string. Thank you guys for watching this video till end, and I believe you've learned one or two things in this video. Kindly drop a positive comment and don't forget to like the video, share it within your friends, and if you are yet to subscribe, kindly subscribe to this channel as it will motivate me to produce more useful video. Thank you.